5.5, solving equations by graphing. So we're going to be solving equations with one variable. So not a system of equations here. We've got one equation with one variable in both of these examples. But what we're going to do is to make two equations out of this by setting both sides of the equation equal to y. Okay, so the left side of this, I'm going to write, okay, y equals 1/2 x minus 3. And for the right side, I'll do y equals 2x. Okay, I'm going to graph both of these. These would both be straight lines, right? Then I'll find the intersection. So if I was solving this system, when I graph both lines, the intersection would be an xy pair, right? And that would be my solution to this system. But really, I'm solving this equation. So I'm saying that if y is equal to both of these things, then both of these things are equal to each other, right? And so really all I want is the x-coordinate. I want to find the x-coordinate that will work in this equation, and that is going to be the x-coordinate of the intersection. So the solution is going to be just the x-coordinate, not the xy pair, okay? All right, so let's start graphing these. These are already in y equals mx plus b form, right? For this blue one, the slope would be 1/2, and the y-intercept would be -3. Okay. For this one, my slope is 2, or you could think of that as 2/1, and then the y-intercept would be 0 because I could put a +0 at the end. All right. So let's see. I'll start with the y-intercept here at -3. There it is, and then I'll use the slope to get to a second point. So I'll go up 1 to the right 2 from there, and I'll keep going up 1 to the right 2 till I get to the edge of the graph there. And I could also go down 1 to the left 2 because this is equal to -1 over -2. So let's go down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. Okay, and then I've got my first line drawn. The more points you plot, the better, because hopefully one of those points I just plotted is the intersection. So let's see if that works out like that. All right, for the red equation here, y-intercept is 0 and the slope is 2. So I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and that's also -2 over -1. So I can go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. Okay, and I did plot the same point twice. Once for graphing each of these lines, and so then I know that that point is definitely the intersection. So this would be the point -2, -4, but that's not my solution. I want only the x-coordinate because I'm solving this equation that only has x's in it. So my solution then is going to be x equals -2, just the x-coordinate there. Okay. All right, let's try another out. So I'll color code these again. So left side, I'll write that as -4 plus 3x. And I'm just going to, this isn't quite in y equals mx plus b form yet. The y is isolated, but I want to switch the order of the terms on the right there. Then it's in y equals mx plus b form, so then I can see that the slope here would be 3, or 3/1, and the y-intercept would be -4. Okay, I had to use that space down there. Okay, all right, let's try on this side. I've got -3x, y equals -3x plus 2, so my slope is -3. I can think of that as -3/1 or 3/1. Those are both -3, right? And my y-intercept is 2. Okay, so the blue one, -4, there's my y-intercept. And then from there, I'm going to go up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. Okay. And graph this line quickly. All right, and then for the red one, y-intercept is 2, and the slope is -3/1, so I'll go down 3 to the right 1, down 3 to the right 1, and I could also go up 3 to the left 1. And then I can see that I plotted the same point twice once for each line, so I know that the intersection then would be the point 1, -1. And then I just want to use the x-coordinate So that's the x-coordinate. On both of these, you could test this out, right? In the original equation, you could plug in 1 for x, and it should balance out the equation. Same thing over here, okay? You could also, by the way, solve these equations by combining the like terms, like maybe subtracting 1/2 x from both sides and then working from there. Or this one, you could add 3x to both sides and work from there. But this is just a different way to solve equations like this. Okay, so to be totally honest, I wouldn't usually solve an equation like this if I had a choice of the method. I would just combine my x terms. But this method is really helpful when we're dealing with absolute value equations of a certain type. So if you look down at this example down here, we've got absolute value on both sides of the equation. We've only got one variable. So we can use the same kind of an idea that we did with the linear equations on the previous page. Okay, so one thing you have to know, an absolute value equation in the following form has two different related equations. So first you can write an equation that looks just the same without the absolute value symbol. And then you'd want a second equation where you change the sign of everything on the right side. So I'm taking the opposite of cx plus d on the right side. Okay, so let's just write those equations on this example as we go, and we'll go through the steps here. So first, I'm going to be graphing, since I'm going to have two different equations, I'm going to be graphing two different, using two different graphs here. Okay, so on this left graph, I'm going to just pretend there's no absolute value symbol, and I'm going to be working with this. On the other side here, I'm going to take 2x plus 2 on the left again, but on the right side, I'm going to take the opposite of the quantity x minus 2. And it's important that you're taking the opposite of that whole quantity, right? Not just putting a negative in front of the x. And it shouldn't write it as negative x minus 2 without parentheses, because we're going to want to distribute here. And so we'll get 2x plus 2 equals negative x plus 2. Okay? So we wrote both related equations. Okay? Now for the first equation, set both sides equal to y and graph. So now we're going to take this and do exactly what we did on the previous page. Okay, so we're going to split it into two equations where y equals both sides. We'll do the same thing with this side. So let's go ahead and do that. We're going to do these two steps here where we find the x-coordinate of the intersection. So on the left side here, I'll do y equals 2x plus 2. On the right side, I'll do y equals x minus 2. Okay. All right, so here I can see, okay, my slope is 2 or 2 over 1, and my y-intercept is also 2. Here, my slope is 1 or 1 over 1, and my y-intercept is going to be negative 2. Okay, so my blue equation, let's see, y-intercept of 2, and I'll go up 2 to the right 1 from there. I could also go down 2 to the left 1. Make as many points as I can. Then even if you don't have a ruler, you can draw a pretty nice line. All right. And then let's graph this red one. So y-intercept is negative 2, and the slope is 1 over 1. So I'll go up 1 to the right 1 all the way. And I'll also go down 1 to the left 1. And way at the bottom of the page there, I found the intersection. So it just barely fit on the provided graph. So that's good news. Okay, so I can see here the intersection is the point -4, -6. And then I only need the x-coordinate there. So x would equal -4, okay? So I'll just circle this. It's not gonna be my final answer, but I'm gonna just put that to the side. If I was just solving this equation, that would be my solution, right? So now let's go ahead and do the same thing on this other graph. Okay, so I'll split this into 2 again. So y equals 2x plus 2, and y is going to equal -x plus 2. Right. Here, maybe I'll separate this out like this. So on this left equation, my slope is 2 over 1, or just 2. and my y-intercept's also 2. Hey, that's the same equation from over there, right? And then here my slope is -1, which you could think of like that or like this for rise over run purposes. And my y-intercept is 2. Okay, so let's see here. Y-intercept of 2, up 2 to the right 1, up 2 to the right 1, down to the left 1, all the way down. And then, well, I'll draw on the line. Okay, and then I'll try this one. So I've got y-intercept of 2 and a slope of -1, down 1 to the right 1, or up 1 to the left 1. I'm not going to draw all the points because I already found the intersection there. Okay, so there's my second line, and I can see here the intersection is 0, 2, so that means that my x coordinate there is going to be 0, okay? So now if we look at the final step in the directions there, you should have 2 solutions. Here we have our 2 solutions, one from each graphed system of equations, and we're going to check both of them. So that means I'm going to plug these into the original equation, into this equation, and see if they actually work. It's possible sometimes that you'll get an extraneous solution that won't work. And also, if you made a mistake at some point, you'd be able to catch it by checking your answer. So let's check this one. I'm going to go back. I'll do my check here before I decide if this is an actual legitimate answer. So I'm plugging -4 in for x. And there's 2 places to plug in the -4. And I'm going to see if this actually balances out. So on the left side here, let's see, I've got -8 plus 2. On the right side, this is -6. And the absolute value of -6 does equal the absolute value of -6. They both equal +6. So this does check out. So that means that this is a legitimate answer. Okay, so now let's check this one. I'm going back to the original equation again, and I'm plugging in 0 for x. Okay, so here 2 times 0 is 0, so I've got 0 plus 2, and then I've got 0 minus 2. And so here I've got the absolute value of 2 is equal to the absolute value of -2. Well, the absolute value of 2 is 2, and the absolute value of -2 is also 2. So this one checks out as well. So that means this is also a good answer. Okay? All right, let's try another example like this out on the next page. Okay, so I've got 2 absolute value. I've only got one variable, and there's an absolute value that's equal to another absolute value. So let's split this into the 2 equations first. So I'll write it just as is without absolute value brackets first. And then over here, I'm going to write the left side as is without absolute value, but the right side, I'm going to change the signs. So I'm going to take the opposite of -x plus 4. Okay. All right. So let's start with this one. Now I'll split this into 2 equations. Okay, my slope is 1, or 1 over 1, and my y-intercept is -6. Okay, so let's see, -6, and I'll go up 1 to the right 1 from there. Okay, there's the first equation, and then I've got a y-intercept of -1 over 1, or 1 over -1, and then y-intercept is 4. Okay, so I'll go down 1 to the right 1 from there, or up up one to the left one, and then I can see where the intersection is. That's good. Okay, so my intersection here is 5, -1, but I just want to look at the x coordinate of the intersection. So I'm going to check out x equals 5. Okay. So here, let's go ahead and check it out now. Let's plug it in the original equation. So the original equation, the one with the absolute values, so I'm plugging in 5 for x. On both sides, and then I'm seeing if it balances out. So on the left side, I've got the absolute value of -1. On the right side, this would also be the absolute value of -1. So those both equal 1. It does check out, so this is a solution. Okay, all right. So now let's repeat that whole process over here. So I'm going to split this into 2 parts. Oh, I need to distribute the negative over there. So for my other equation, since I already wrote that side, so this would come out to positive x minus 4 after I distribute, right? Okay, there's my 2 equations. So I've got a slope of 1 over 1, or -1 over -1, and a y-intercept of -6. For this one, same slope. And then a y-intercept of -4. Okay, so let's see, -6. I'll go up 1 to the right 1 from there. Okay, and then a y-intercept of -4. And when I go up 1 to the right 1 from here, I'm going to wind up with 2 parallel lines. So they're never going to intersect because they're parallel. They have the same slope. So this system over here, there's no solution from this side. So there's nothing for me to check there. So that means my only solution is x equals 5 on this particular problem. Okay. All right. Now we've got a word problem. A rental car company, Company A, charges $3.25 per mile plus a flat fee of $125 a week. So rental car Company C charges $3.30 per mile plus a flat fee of $115 per week. After how many miles are the total costs the same at Company A and Company C? Okay, so let's think about this. Company A, that's the $3.25 per mile plus $125 flat fee. So let's say that x is the number of miles. So I can say 325 times x plus 125. That's going to represent the amount of money that it costs, right? So if you just drove 1 mile, it'd be $3.25 plus $125. But you know, the more miles you drive, the more it costs. And then let's look at our other one. Company C is $3.30 per mile plus $115 flat fee. Oops, I forgot the x there. $3.30 per mile plus $115. Okay, so it's asking when are the prices going to be the same? So you could say, okay, well I can see for what x value are these 2 expressions going to be equal to each other. Okay, so now I've got this equation here. I'll just rewrite it here. I've got this equation, and it's one of these equations. It's not an absolute value one, but it is one where I've got one variable, and I can solve this by graphing. So you could set the left side equal to y, and you could set the right side equal to y. And we can graph them and find the intersection, and then we'll use the x-coordinate of the intersection. Okay. Now you could graph this by hand, but it would be a little bit difficult because The slope isn't written in fraction form, although you could rewrite it in fraction form. And then we've got relatively large numbers for the y-intercept. So it would be kind of a pain to graph by hand, but it says use a graphing calculator to solve. So that's what I'm going to do. I'm going to use this TI-84 calculator to graph both of these equations. Okay. So the first thing you want to do is go to the y equals button in the top left corner. Okay. I've already got some other equations in here, so I'm just going to hit clear on each of those to clear them out. And then you need to have equations in y equals form to graph them on these calculators, but these are already both in y equals form. So I'll type that first equation in as 3.25x, and when you do x, it's not, some people try to use the this button, that's multiply, or they'll use the alpha button x, like there's these little green letters on my calculator, but I don't want to use that. I want to use this variable button right here. It's right below mode. And it says x, comma t, comma theta, comma n. I'm using that one for x. And then plus 125. Okay. And if I wanted to see just that line drawn, I'd hit the graph button up here. But I want this to graph both of these. Okay. So I'm going to scroll down to my second equation there. And I'll type in 3.30. There's my x button again, plus 115. Okay. So now I'm going to hit the graph button. And you may have a different zoom going on your graph. So the standard zoom, I'm just hitting the zoom button here. Probably on most calculators you'd see the standard zoom, which will give you 10 ticks in each direction. And when you do that, we can't see anything at all because the y-intercept is at 125 and 115, so it's way above the graph I can see here. So you might have to play around with the zoom. You can just zoom out. So you hit the zoom button and zoom out. Or one thing that I like to do is zoom fit. So if you go down for a while, there's zoom fit. It's the 10th option. So I go highlight that and hit enter. And then it'll make sure that you can at least see the equations. Now I can see those equations. They look like parallel lines. But wait a second. These aren't parallel lines because the slopes are slightly different, right? The slope is not the same as this one. So they are eventually going to intersect. So what I'm going to do is zoom out until I can see the intersection. So I'm going to hit the zoom button and I'm going to choose zoom out, and then you have to hit enter once more because you could move the cursor and zoom out on a different area, but I'm just going to zoom out where I already am. I still can't see an intersection, so I'm just going to keep zooming out. Okay, now it's hard to tell if I can see an intersection or not. I think just to be safe, I'm going to zoom out once more because it might be slightly off the screen. Okay, and now what I'm going to do is use the calc menu. So it's right above trace. So you have to hit second and then trace to get to the calc menu. And then you can see there's intersect. So I'm going to choose intersect because I'm looking for the intersection. And it's going to ask me first curve and then second curve. I'm just going to hit enter twice to answer those questions because there's only, when it says curve, it means equation. There's only 2 equations graphed here, but you could graph more than 2 equations. But since there's only 2, I hit enter, and then it says second curve, hit enter again, and then guess. It doesn't really matter because there's only 1 intersection, so I'm just going to hit enter a 3rd time, and then really small, it's written down at the bottom. It says intersection. So really, and it tells me the intersection. So the intersection is going to be the point 200, 775. Okay? And we only need the x coordinate here. That is the x value that is going to solve this system. Okay? So it says after how many miles? So that means 200 miles. At 200 miles, the cost is going to be the same. It's going to be $775. So that would be what the actual cost is. But it's going to be the same when you drive 200 miles. And there you go. Okay? And that's the end of the section. See you next time.